Okay, so here we are today. Today's lesson, I want to talk about Revit objects. So the thing that's important, or the thing about object, or the thing about Revit, is that rather than working like traditional CAD, it works with objects instead of lines and arcs and circles. So the objects are things like doors and walls and windows and roofs, these types of things. So it's thought of as a whole object, not just a collection of lines that might make up a door. So that kind of relationship is really important. It's kind of fundamental to what Revit is all about, because by taking objects, we can start to build rules and expected behaviors out of these objects. So the objects themselves understand what they are and understand how they relate to other things within your design and within your model. And because of these kinds of rules, it makes actually putting together a building much simpler and easier to make a representation of what you want, because these things have behaviors that are going to be similar to what you would find in the real world. So you can think about your design in terms of objects rather than in terms of lines and how you represent something. The representation is kind of already taken care of for you. It's just a matter of getting objects in the right position and controlling some aspects of that object and the way you want it to come out. So that's really fundamental to what Revit is all about and how you work with it. So it's important to understand that relationship and understand that you're working through objects. So when you run into things or trying to think about how Revit is working with something or how you might design something, you want to think of in terms of these objects rather than in lines or what it's supposed to look like. So let's go back for just a minute and let's talk about how CAD kind of handles this kind of thing, handles representation, and what the role of a line really is when we're talking about representation, when we're talking about computer-aided drafting in general. So when you're working with CAD, really the lines themselves, they have no meaning in and of themselves. They're kind of alone, if you will. So they gain meaning from the context of what's around them. So take, for example, this line that I have shown. Because there are no other lines around this thing, there's no way for anyone to know what that actually represents. At this point, it could be a fence, or it could be simply a piece of text that maybe you're starting, maybe it's the letter I. It could be anything. It doesn't have any meaning. The line itself does not have any meaning until it starts having context. So if I did something like that, I add 3 more lines to that first line. Now it starts to have some meaning, but it's still, the picture may not be completely clear. If I was to ask you, what is this now? You might say, oh, it's a wall. Or some people might say, oh, it's a column. But we don't know if it's up or down. We don't know if we're looking in plan. So we're really not sure yet what that thing is. So even though I've added some more lines, I still don't necessarily know what this thing is. Right? But now if I add this, now the people who guessed walls, maybe you're right. Maybe you're not. Maybe if you're guessing column, probably isn't that. Columns don't usually have that relationship to other lines. They wouldn't sit on the edge of a floor or something like that. So now we have a little more meaning, or now we might be able to think of it as possibly what it is. If I add the final piece here, it's actually representing a door. So I think you get the idea that what's happening here is that lines within the CAD world are really deriving their meaning from their context, and you have to have the other lines there in order for you as the viewer to understand, right? So I can modify properties on an individual line, but it still doesn't really provide any meaning. I can make like the walls of this a little thicker to try to help describe some meaning, but it isn't meaning in and of itself, the properties of those lines. And the lines are really just for representation. They have no other meaning. I bring whatever that is to this drawing. If I wasn't an architect, I still may not know what this is necessarily. As architects, as trained as architects, or people who work with plans all the time, we know that what I'm seeing now is a door in a plan view. But somebody who doesn't look at drawings all the time may not even know what that is. So there still can be some ambiguity there. So anyhow, this is just an example of how lines derive meaning from context, and that they're for just representation. So in Revit, the relationship between those things is a little bit different, because these things are actual objects or virtual versions of that object. So the thing contains more than just this representational geometry. It contains instructions of what it's supposed to look like in plan, what it's supposed to look like from 3D, what materials it has. So this door, if it was in Revit, is known to the system as a door. So it has a bunch of properties that aren't just about geometry. It's about how much it costs. All of these kind of things are embedded into that object to make it have more meaning and be more useful down the road than to be just representational as it would be in CAD. So this door as the example, right? It can contain multiple representations. I place a door one time, and it knows, well, if I'm looking at this thing in plan, it's supposed to look like this. If I look at it in elevation or section, it probably should look like what's shown in the middle. Or if I see it in 3D, it should look like this. And there it has some material qualities of, it looks like it's a wood door with a wooden frame that's painted brown or whatever. But the idea is that it contains a lot more than just the geometry. It contains the representations and other things as well. So each of these elements that are inside of Revit, they follow a really strict hierarchy. And this hierarchy of elements or objects in Revit is a really fundamental thing to understand. It's something that you probably want to write down. It's something that you want to keep track of, and just remember that everything kind of follows this fundamental order. And when you think about lots of pieces of Revit, the way things work is it all goes back to the understanding of this kind of element hierarchy and how it works. So sitting at the top of this element hierarchy is Revit needs to know the category of what an element is. So what is this thing? Is it a wall? Is it a door? Is it a window? Etc. Everything has some kind of category that has to fall into. So, you can imagine if we have this set of categories, sometimes there are things that kind of are in between, so we have to make a choice as to what that's going to be. Is a fire alarm box, if it doesn't have a category, is it electrical? Is it fire protection? What is that thing? So we kind of have to figure out what the category is, but there's always generic. We can always use that as a category if we don't have a spot for everything. But at the top of the hierarchy, everything has to be assigned some kind of category, so Revit knows what is this thing, and then understands some things about that, and it affects other functions down the line. So after category is the family, which family is kind of a funny term, and I had a hard time with it when I first started using Revit. But family is really kind of like the DNA of what an object might be. So it's kind of, if you think about it, it's generally kind of, what is the geometry of this thing? Is it a door, a door with a window light or without a window light? Those are probably different families because they're both doors, yes, but they have kind of a fundamental difference in that one has a window in it and one does not have a window. Now, you might think of one door that has the window light could be lots of different sizes, and that's probably the same family. You wouldn't make a different family for different sized windows. But a door that has a window versus a door that doesn't have a window, those are kind of fundamentally different because they're different geometrically. So if you think of family as kind of the DNA or the essence of what that thing is. Now, it's a somewhat loose description because the author of the family can control where that line kind of is. You could make a family that is, a door for a tiny little mouse, or all the way up to an airplane going through the wall. That could be one family, but they're probably fundamentally different, so you might want to break those into two families. But the author of the family has some control over that. So it's a little bit loose description, but if you generally think of a family as kind of the DNA of what that thing is. And sitting below family, once we've decided what this thing is and what kind of the general DNA of this thing is we have types. So types are kind of groups of something. So I have a family that is a door with a window light, let's say, and I have one that is a 36 by 72 inch door or 80 inch door, and I have another door that's bigger, that's say a 4-foot wide door. So those are two different types. So I have a 48-inch door and I have a 36-inch door. But still they're the same family because both of the doors are rectangular. They're both made out of wood. They both have a window light on them. They're just different types. They're different sizes. So the different types, the thing that's important to remember is if I have, say, a type, a 48-inch door, and I make some change to it, so I change the door types that are 48 inches, and I change them from being wood to being metal. A change at the type level of elements in Revit affects all the objects within your model. So every place that door exists, that 48-inch door that was wood, if the material is a type property and it's part of the door type, as soon as I change it to metal, every single one in the whole project will change. So the power at the type level is very, you have to be careful making changes at the type level because it can affect many, many, many objects in your project all at one time with a change to it. So sitting below type after that is instance. So the instance is the actual one that you put in your model. So this would be something that an instance of something contains very specific information about that particular door. So if we stay with our door example, we have two 48-inch doors, but they're in two different rooms. So they would surely get two different room numbers or two different door numbers respectively. Or perhaps one of those doors happens to go into a classroom and another one of those doors, still a 48-inch door, still the same wood, all of those things are the same. It goes into a storage room. So instead of having a classroom lock on it, it has a storeroom lock on it, which is a different hardware set. So specific information about an individual item, that's at the instance level. So this element hierarchy that we have, the category, family, type, and instance, it is pervasive throughout Revit. Every single object that you place follows this pattern, and you can trace back what you want to change or things about that object back up through this chain. So it's really important to understand this kind of element hierarchy within Revit. And as you work with Revit, it'll start to become more and more kind of second nature, and you'll understand what this hierarchy kind of means. But for now, note it down, think of it in your head. We'll certainly talk about it over and over and over again during the class. So objects that we create are spawned, or we produce types of objects. So we have the family and then we have the type. So if you think about types, so I already talked about this a little bit as the doors, they're kind of like you can hold default values that are very common for this particular thing. So in this example, I'm showing a 6'8" by a 2'6" door and a 3'0" by a 7'0" door. And there could be another bunch of sizes as well. So you think about the way that item typically comes, you can make types for that so you don't have to fill in those values. So those are kind of standard pieces that you would use, so you can make types from these things. So what's nice about this is types are really easy. You can swap types in and out. So you can place something, and then if you find out later you need to make a different size or whatever, you can swap out a different type really easily as well. Now objects can be swapped between categories as well. So say for example you would place one of those doors at the top that's just a single solid panel door somewhere, and then later your client came along and they said, boy, it'd really be nice if I had French doors. Actually, this is kind of at my house. I have this. I have a back door that's just a regular single door, and it'd be really nice if I could have French doors. So if I could swap it out like I could in the computer, it would be super easy. I'd have to do a whole bunch of work to get it to change at my house. But so if I had one of these doors placed in my model, I could very easily say, oh, you know what? I'd like to swap out to use a different family in place of this. So I want to use, instead of that single flush door, I'm going to use this French door instead. Since they're in the same category, I'm changing from a door to a door. It has no problem. Revit has no problem switching that thing out. Even though it's twice as big, it has no problem swapping that out, because we position it in space, and it just changes the size as it needs to. Now, there may be things around it that affect that, so you can't swap them out without affecting some of the other parts of the model. You have to move those around a bit. But still, anything in one category can be swapped for anything for another category. Now, if you wanted to make a swap, like I placed a window in this position, and later come along and say, I would like to have a door in this position instead, that kind of swap is not possible because I'm switching categories. So if you remember, at the top of the hierarchy was, what is this thing? Is it a door or is it a window? Well, doors and windows are fundamentally different things, at least to Revit they are. So swapping out across categories is not permitted. So as long as they're the same category thing, we can swap them. If they're different categories, you have to delete and place a new object of that other type. So that's kind of an important thing to remember. But the swapping of types and swapping of category to category is definitely something that you use as you're working with Revit, because a lot of times you don't necessarily know if you want this kind of wall or that kind of wall. In fact, I used to work with somebody when we first started working with this kind of software. She didn't like using it because she didn't feel like, well, I don't know all this information about this wall, but it wants me to know. Well, it wants me to put a brick wall or whatever kind of wall in, and I don't know that. It's not a problem. You can put something with as much information as you know at the time. So I know that it's going to be block. But maybe I don't know the exact finishes. So I might just place an 8-inch generic wall and later come back and swap that out for something more specific. So this idea of swapping is kind of fundamental to the way you want to work with Revit. Is know that you're kind of placing things generically, possibly at first, and coming back and refining those as you get more information about your design. This is very much like the way kind of typical design works anyways, is that we place down, a lot of times we'll just sketch something, right? And then after we get some more information, or after that idea kind of gels in our head, or we decide on the sketch, then we'll start drawing it with a little more refinement as we know more information about the object. No different here in Revit. It kind of leverages that whole idea of being able to swap and constantly change. So an instance of an object, so that's the bottom of this hierarchy, is the actual thing that you place. So the family is kind of an abstract concept of the thing, of what's going to be created. So here you can see, I actually am showing what a family looks like in a family editor. You need to know all of these things, or the family knows all these things about that object, which it uses to control its geometry. Well, when you place an instance, you just kind of have to say, oh, I want it to be this size, and it'll change and do what you want to. But the instance is a unique element within the project that you've placed. And there can be many, many identical doors just like this. You can have 5 or 10 French doors like this. And they're all unique instances within the model. All right, so the instance is the actual placement of the thing. And how it's going to be affected is what parameters are on that instance and things like that. So this whole concept of using objects is really not that new of a concept to the design field in general, or new to architects, right? When you think of your design, you kind of think of objects. In the past, we were forced to represent those objects with lines so we could communicate them to people. When you're working with Revit as a software, you can still kind of think in this object type of mindset, and it's like we're picking from a catalog. So here I'm showing, for example, a page from the Anderson window catalog for their 400 series casement windows. So you can kind of think of this as these casement windows that Anderson makes are the family, right? So the family is a 400 series casement window. And I know that I want a casement window, so I'm going to place that thing. And the types that in terms of Revit, to speak to terms of Revit, the types are all the different sizes that you see listed on this Anderson window page. So the family is the casement window. The type is all the different sizes that I might be able to place. So all the standard sizes that Anderson makes would probably be types within the casement window. and then when I actually place the window, that's the instance of the window that I'm using. Now, another thing that kind of comes along for the ride with using objects is this notion that design intent can be encoded into the objects. So it's kind of a funny term. I've struggled with the term design intent for a while. When I first started using Revit, didn't really know what is design intent, what does that mean? I don't get it. It doesn't make any sense to me. So the idea of design intent is that usually when you put something into your design, you have a notion of how those things are supposed to be related to one another, and Revit tries to capture some of that. It doesn't capture all of it, but it tries to capture some of it. So for example here, when you place walls in this little example, if you place walls in that 90-degree configuration, if I was to move the wall that's horizontal there, the other walls would maintain that connection point. I don't need a stretch command like I do in AutoCAD or CAD, because when I move that wall, it knows, well, those walls were joined when they made them, so I should probably keep those connections. There's ways to break that connection, but it assumes that that corner was supposed to be 90 degrees, and it should always maintain that connection. So that's an example of design intent. Another example of design intent that is maybe more intentional, but you can build these rules around and within your project. So here I'm showing this equality constraint. So some windows were placed into this wall, and I wanted to make sure that they were equally spaced from the edges and between each other. I wanted equality constraints. So I can place a constraint, or I can build a relationship within my project, and then when I change those outside wall dimensions to make them wider to one another, not only is the L connection maintained, but the equality constraint that I built, that was my intent, I want those always to be equal, that's maintained as well. So this idea of design intent helps you make sure that all the objects within your design maintain the relationship to each other. And Revit builds some of the background by itself, but you can also build these relationships on your own. So that's one of those things where it doesn't necessarily depend on context to define these elements. It knows what these things are, so it knows how these things are supposed to react to each other. So another example of items knowing, or something that can happen when you have rules or when you have objects, you can write rules that the objects themselves will follow and behave, because they know that these objects are, like back from the beginning of the lecture, they're not just lines, they're objects, so they know that they should behave in certain ways. So for example, when the roof is placed over the top of these 4 walls in the second image here, the walls automatically know, or they will ask you, I see that you placed a roof above me, above my walls, or above these walls that you drew. Normally, walls go up and touch roofs. Should I make that happen? So there's an example where Revit is trying to figure out what your intent was. Does every time a roof appears above a wall, does it attach? No. But most of the time, maybe 85% of the time it does, maybe even more than 85%. So it'll ask you, do you want me to connect these two elements? So you can say, yes, I'd like those two to connect. So then the wall will fill into that gable end instead of just being flat across the top, and it'll also be now connected to that roof. So if I later come along and move the roof up to accommodate a second floor or something, like in the second image there, those walls will stay connected to that roof. I don't have to remember to go back and move those later on. They have a relationship, the wall to roof, so anytime that roof is moved, the wall will move along with it. So that's another example of getting design intent encoded into the objects, so when changes happen, some of the change is managed within Revit itself. So really what we're doing in Revit, one of the, kind of, when you boil everything down, is we're really just selecting what it is that we'd like. So I want to place a wall and I want it to be 8 inches thick or whatever. You pick something as close as you can. So as much information as you know about it. So go back to my person who didn't want to use the software because she didn't know everything about a wall. You don't need to know everything about the wall when you place it. If you know it's probably going to be about 8 inches thick, then place a wall that's about 8 inches thick. It doesn't matter what it's made up of. It can all just be generic, as long as it's as close as you know at the time you're placing it. So you select what you want, and then you place that item into your model. So once you figure out what you want and you figure out what it's supposed to be, so the size or whatever it is, then you position it in your model, and it is there until you want to come back and make a change to it. So if, in this example, I've placed a wall and I've placed a window that's a fixed window. If I come back later on and decide that I want it to be a different size, or decide that I want it to be a different, instead of fixed, it's supposed to be a double hung window, I can swap that out later. So being able to swap the pieces out, because you're not worrying about the representation of it, it's okay to make a mistake or make a guess that's not exactly right, because the work is much lower than it would be if you were drawing this in CAD. In CAD, if I had to go back and switch that window out, it might be a more difficult problem, because I have to switch it out in multiple places. I have to make sure it's represented correctly. So here inside of Revit, a lot of that is managed, so it doesn't become as big of a deal to swap things out later. So don't be afraid to place something generically as a placeholder, to know that you want something there. I know I want a window here, but I don't know exactly what it's supposed to look like or how big it's supposed to be yet. Just put a window in and then go back and figure it out once you have the information. So, and then finally, really here is that every single thing in Revit, I've talked about mostly physical building objects as being having this hierarchy and being objects, but really every single thing within Revit really is an object. It's because Revit is working as a database and representing things based on what's in the database, not representing line, not allowing you just to draw lines, vectors on a screen. Every single thing is an element or is an object. So in this example, the dimensions are an object, the section marker, the wall tag, the text, the door tag, all of those are objects. Even the views themselves are objects. So anything in Revit is an object, and then the properties, the type and the instance properties of the element. So we talked about types and instances in the hierarchy. Well, there's type properties and there's instance properties, and those properties working together control that object or do things with that object. So everything is an object, and everything has type and instance properties, and that's how you start to control and work with things in Revit. Now, because you're working through these properties, sometimes it becomes frustrating to try to do something. You want to change, say, the swing on the door. Instead of being an arc, you want to be a diagonal line, something like that. It's a little bit more challenging to make a change to that object. It's not impossible. It's just harder to do than if I was working in CAD. However, the power down the road is that those objects are starting to handle relationships and display representations, those kind of things, the way they're going to show in a view. All of those things start to be handled by the object, so you can define that in the object, and it has effects across your entire project in every view. So you don't have to worry about that. You really just have to worry about getting the right object in the right place. So that's kind of some of the fundamental things, and thinking about Revit as working with objects. And as we go forward in this class, all of these things will become, more solid in our minds, and as we practice things in class, those kind of things. But it's important to kind of have this foundation that everything is an object. It follows this hierarchy of category, family, type, and instance, and then the parameters or the properties on those elements help you control and manipulate the objects. And then we'll cover questions in class, but thank you for watching this video. I hope you found, so I hope there's good information there. There's for sure questions that I'll ask in class about it, and we'll see you next time.